Good afternoon, and thank you all for registering, and welcome to our first SpiroExpert live web chat. Hopefully this will be one of many Spyro web chats that will bring you over the course of this year. Each month we'll try to bring you a different topic ranging from pressurization, hydraulic balancing, system water analysis to VDI. During the course of this session, we will be discussing deaeration and degassing. You'll have the option to put questions through the chat. We'll try to answer as many questions as we can towards the end of the session, within the time frame permitting. Please let me introduce myself. My name is Tony Carling, and I am the National Key Account Manager for Spirotech. And I'll introduce my colleague, Steve.
Hi, I'm Steve Simmons. I'm a Special Projects Engineer, as well as doing specification work with the consultants in my area. I'm also available to come nationwide to investigate and diagnose any problematic systems you may have and find solutions for you, as well as so you get an explanation of why you've been having problems, as well as a way to fix them.
Great, Steve. Thanks for that. I would like to run over some frequently asked questions that we get asked here at Spirotech regarding deaeration and degassing.
Fantastic.
Okay, so the first question that we get asked quite a lot is, we hear the terms Spirotop, Spirovent, and Spirotech Superior. Could you please explain to our audience the different descriptions in those terms?
Okay. Spirotech is the company. All the other terms, Spyro something, relate to a family or a group of products with a common theme. So a Spirotop will cover any air vent. There is no Spirotop. Spirotop just means it's an air vent, and then we have to define exactly which one you need. With Spirovent, it's anything that's exclusively for removing air. This Spirovent Superior is a particular type, has a different way of doing it to the normal Spirovent. But say every one of those terms indicates a family of product within the entire Spirotech offering.
Yeah, so the brand names relate to the products that we manufacture and we sell. Okay.
Yes.
Thanks, Dave. Another question that I personally frequently get asked on quite a daily basis is, instead of installing a separate air separator on the floor and a separate dirt separator on the return, we manufacture a combined air and dirt separator in one unit. Yeah. So where would you install a combined air and dirt separator in a closed system?
Well, our recommendation on a heating system is the separate units, because the deaeration requires, the inline deaeration, requires the increasing temperature to release the air from the water that the unit can then remove. The combined unit is a compromise. It does two functions, but it obviously can't do them both in the same place.
Correct.
To maximum effectiveness. Where would you put one? You could put it where you put either a deaerator or a dirt separator, but be aware that whichever place you put it, you're ideal for one function, the other function is going to be compromised.
Yes.
And again, it depends on what the system is doing. So if you're installing a whole new system with heat emitters, heat generator, circulation, the whole lot is brand new, I would suggest you put a combined unit as a deaerator, and you focus on the deaeration to keep the system healthy and prevent the accumulation of dirt in the first place.
Okay.
But if you are putting a new boiler onto an old system, then your priority really is to protect that new boiler, that investment. So you would be better off to put it in as a dirt separator and take the reduced deaeration as a small hit. Your deaeration performance will be about 7 to 10% lower, because you're using lower temperature, and therefore there's not much air out solution, and the unit can't access it and can't remove it.
So would you always lean to installing a separate air on the floor and a separate dirt on the return?
That is the best engineered solution.
Yeah.
But I say there may be other factors which mitigate for a combined unit, and you are in a heating system, you're going to compromise. On a cooling system, The
Correct.
combined unit is absolutely perfect because the return is the hottest part.
Correct. Yeah. Okay, Steve, thanks for that. Appreciate it. So, what would you say that has any relation to Henry's law?
Well, as I said, that the inline units rely on the temperature increasing to release the air from the solution, and the unit can only remove air that's out of solution.
Okay.
So if you're working at a lower temperature, i.e. on the return, then there is less air out of solution, so the unit cannot remove as much from the system as a whole.
Correct. Okay. Okay, thanks, Dave. Appreciate it. What guarantee does Spirotech offer on the brass AAV, RV2, and mild steel PN16 flange air separator products?
Okay, the brass units come with a 20-year warranty.
They do.
There's really not a lot that we don't find. And the steel units, steel body units Inline, come with a 5-year warranty.
The standard.
As standard on the standard range of products. We can obviously make specials to any type that you need, and they only come with a 3-year warranty.
Okay, and we can obviously make them stainless steel if the customer requires.
Different materials, different pressures, different.
Just suit any application.
Just get in touch and ask us what you need, and we can probably come up with a solution.
Excellent, Steve. Thank you for that. Another good question that we get asked quite a lot is, we get asked about the technology of the Spyro tube that's inside of all of our units.
Yes.
What would you say are some of the Spirotech's USPs on the Spyro tube?
Well, this is the Spyro tube, which is actually quite simple, but this is the same piece that goes into every item. I don't know how well this camera will pick this up, but you can see pretty much through the unit. This means there's very limited resistance in flow, so it doesn't cause an impact like a filter would, or other types which have different ways of doing the internal mechanism. But this unit is highly efficient. As far as I know, it's the most efficient separation element on the market, and provides the least resistance to flow. So any other alternative product you may look at, you'll be compromising on some of those factors. Other things that we also do is, whereas many other types put a 15mm nipple on the top and just screw a standard air vent on the top, we only take the top element of, for instance, the RV2 here. We just take this top element and then fix it specially and with an extended float. So whereas with our standard product we have about a 25mm gap between the water and the air vent valve, on the commercial units that's increased to 150mm to prevent the possibility of water getting in contact with the air valve and causing failure.
So does the Spyro tube work in a centrifugal fashion by forcing the micro bubbles up and out through the EV?
Yeah, it controls the water inside the body of the unit, and air gets forced upwards due to the spiral nature of it, and the dirt goes down obviously under its own buoyancy, under its own weight, and the air goes up with its own buoyancy until it reaches a laminar no flow zone, which is created by the height of the unit and the control by the central Spyro tube. Once it gets out of the main flow, then the air can come out under its own buoyancy, but it needs to be out of the flow, and this helps provide control of that.
And am I right in saying that's copper soldered onto copper using lead-free solder?
Yeah.
Correct. Okay. Thanks, Steve. How would you size an inline air separator? Is this limited to static head height?
Yes. So the main considerations are the maximum flow rates. In general, the domestic range is good for a velocity of 1 metre per second. So the size will change to meet that depending on what sort of connection you have. The standard flow commercial units are 1.5 metre per second velocity, and we do a high flow range which do 3 metres per second flow velocity. Now those are not the maximum. You could put higher velocities through the unit, but what would happen is that the higher the velocity gets, the more the turbulence goes up the unit or down the unit. And so there will come to a point when you exceed those flows, there will be no static area, therefore no separation will occur. You won't damage the unit, but it won't do anything either.
Okay.
So you can exceed the velocity, but you obviously affect the operation, but you won't damage the unit.
Okay. Okay. And is there any limitations with static head height in relation to?
Static head height. Yes.
Is there anything for
Well,
LTHW?
we have a guideline of 15 meters static height above the unit for inline deaeration at 80 degrees C.
Correct. Yeah.
And only 5 meters for typical chilled.
Yeah.
Obviously, with today's drive towards lower flow temperatures, that static height limit is obviously going to reduce for a given temperature, and obviously that also affects the amount of air that's out of solution. So the tricky thing with static height is there are so many variables in the system, pump speed, pressures, etc., that it's very hard to give a definitive empirical answer and say this is the maths, this is where it is. We recommend 15 meters on 80 degrees C because once we've got to that point, that's when we started getting feedback saying it's not doing what I expected it to. So we've had that limit for 40 plus years. It's always been there as far as I've been working with Spirotech for over 20 years. And yes, you do get problems. You're not necessarily going to say at 15 meters you will get a problem, but once you go over 15 meters, you can start to have a problem. We cannot necessarily tell you, yes, you will, or no, you won't have a problem.
So would we, as a guide, we would say 15 meters LTHW and 5 meters?
That is our general guide.
Okay.
We do have a graph, I believe, on our website.
Correct. We do.
It shows that, and it's got a curve, and you just measure off your height and your temperature, and you see if you're above or below the line and what type of solution is going to be optimal.
And then you can select the unit based on that, on those parameters.
Yeah.
Great. Thanks, Steve. How would you correctly size or select a Spirotech vacuum degassing unit?
Right. So when you get to the point where you think you may be getting an ideal solution with an inline unit with airing into a vacuum degasser solution, this works differently. This doesn't rely on the temperature change. It relies on the unit itself can adjust the pressure within itself to reduce pressure. And again, in the line of Henry's law, you reduce the pressure, air comes out of solution.
Correct.
So all you have to do is make sure that the unit is compatible with the pressure at the point of the system where you're going to connect it.
Okay.
We have 5 models now.
We do.
So we have the basic, the baby model, the 250, which goes up to 2.5 bar. The 400, which goes from 1 to 4 bar. The S600, which goes from 2.5 to 6 bar. The 10, which goes from 5 to 10 bar. And the 16, which goes from 9 to 16 bar. So there's an overlap in each time, and it's sometimes a matter of making the best choice out of the range available. It doesn't, as long as you don't exceed the range at either end, that's all you have to do. And they're all available as, most are available with heating or chilled options, so you can have installation on the chilled
installation. Correct. But if the customers have got any questions or they want designs or they want any help selecting the unit, then just come to us and
talk to your local guy. He will always.
We can help you select the correct unit for that application.
Yeah,
that's great, Steve. Thank you for that. So, what would you say is the best position to install the vacuum degassing system unit on the system?
Okay, so you select it on the pressure at the point of connection.
Yeah,
it's essential that you know what that pressure is, both the minimum and the maximum, and that there's no variables in it. So the place that obviously suggests is where the pressurization unit is connected, the neutral point of the system, because that is unaffected by the pumps, and that is the main thing that will change the static height. So we know what the pressure is going to be at the pressurization unit because there's a calculation for it. So if we know what the pressurization is going to do as a minimum and maximum, we can go, yes, this unit meets that window, or we can say, no, there's not one unit that does that. Can we make this tweak to the pressurization performance to accommodate you and make the gas out and make a proper solution that's going to work under all conditions?
Okay.
So it's a matter of we need to look outside more than just the unit.
So would you put it on? So would you say you put it on the hottest part of the system, or would you put it on the return pipe work?
PUs generally go on the return because of the requirement for lower temperatures and to give longevity to the vessel bladder.
Yeah.
So typically, even though they're removing air, because they're not relying on the temperature differential, they actually want to go on the cooler side of the system because that's where the PU is.
Yeah.
So everyone sort of gets it. Oh, right, okay, deaeration goes on the hottest part of the system. Inline deaeration goes on the hottest part of the system. Vacuum degassing actually generally goes on the coolest.
Because that's one of the questions that we get asked all the time. Where would you install a vacuum degassing unit on the system? Like,
Yeah,
I know what you say.
Yeah, so it means, if you think about what it's doing,
yeah,
it's dropping the pressure. So the air comes in the solution. In degassing cases, we want the water, the air in the solution, whereas with the inline, we want it out of solution. So we need it on the opposite side.
Yes, correct. Okay. Yeah, thanks for that, Steve. Why would I select the vacuum degassing unit over, say, an inline air separator? What would you say are the advantages, and also what would you say are the disadvantages?
Well, aside from obviously the requirements of static height and head Henry's law and so forth, what we are seeing really is a general dropping in flow temperatures, which is therefore going to affect the effectiveness of inline equipment.
Okay.
It will still do a job, but obviously it can only do as much as it can given the temperature that you're generating.
Yeah.
Especially if you have a complex system or lots of small pipes, such as underfloor heating or something like that.
Yeah, that's a good one.
That they're very constricted, and you can get more air out with a vacuum degasser than you can with inline units. With the new really small unit, it's really perfect for, I say domestic, it would be quite a large house, admittedly, with quite a large system. You know, you're putting every semi. Or things like a school and things like that, which are relatively low pressure, but you can then do a really good degassing with that, better than you would get with an inline unit. Price is a bit compatible. It's not too dissimilar, and you'll get a better result with, for a similar cost. And especially if you are wanting to retrofit into an older system, if you want to install, say, a steel unit into an older system, you've got to cut out a section, make a bypass, weld some stuff in. You may not be able to do hot works and so forth.
Yeah.
So the cost of the unit is not so much, but the cost of installing it could be a lot. Whereas with a degasser, all you need is a power supply and two 20mm connections into an existing pipe.
So it just hot tap into the connection.
It can be done as a hot tap, which is a lot quicker and easier. So it may cost more for the unit, but it's overall as an installation, it will probably cost less and give you a better outcome.
Okay, I like that, Steve. The final question that I get asked quite a lot is, what, if any, are the maintenance schedules for the Spirotech, Spyrovent, and Spirotech Superior products?
To be honest, on the domestic stuff, there isn't a lot of maintenance at all.
No, maintenance free.
Maintenance free, yeah. And even on the inline units, the only real thing is that the headpiece can be replaced if necessary.
Yeah.
But it's not a.
But that comes with a 20-year guarantee anyway.
On the commercial ones,
yeah,
5-year guarantee. But yeah. But let's say
the brass AAV at the top.
Yes, yeah. But that is not a standard AAV. As I said, we don't just plonk the standard unit on top. It's a special version of it. But then you just unscrew and screw back in. It's a special size. It's not a standard size, but you just buy a replacement, take the other one off. Obviously, isolate the unit, prevent it shushing out the top.
Yeah.
In terms of the vacuum degassers, that's pretty minimal maintenance, to be honest. The solenoid valves, the internal element or the internal diaphragm in the solenoid valve should be replaced annually. It doesn't necessarily have to be so, but we recommend that you probably do it every year. And then every second year, you may consider changing the air vents and possibly the coil of the solenoid valve.
So, would you recommend the superior vacuum degasser is serviced every 6 months, every 12 months, or every so many hours?
Every 12 months.
Or just double check? Yeah.
Every 12 months.
Okay, Steve. Okay. I mean, that's a brief summary of some of the questions we get asked on a daily basis on duration and degassing. If the audience have got any questions, please feel free to email them in, and we'll try to answer them live while we're on this web chat. At the minute, we've got no questions come through. The next topic we're going to do, which is on the 23rd of March, is going to be VDI 2035. So please feel free to join us then. what we're going to do, we're going to send a video recording of this session to everybody's email who's registered, who's on the web chat today. And if there's no questions come through, I'd like to thank everybody for joining and registering. And we hope to see you on the 23rd of March. We'll be discussing VDI water quality. Thank you very much indeed. Thanks, Steve.
Thanks.